sector, and he'll be showing us how to use the visual analytics software for clinical endpoint analysis. Please welcome Mark Lambrecth. Let me get hold of it. Thank you.
I think it's okay. Oh, that's okay. Yeah, it's okay. Okay. Good morning, everyone. I feel a little bit squeezed in between a graphics specialist, cognitive scientist, and then the next speaker talking about what not to do in visualization. Anyhow, coming from SAS, I hope I will bring a specific angle to this day, and that is trying to convince you that visualization goes hand in hand with analytics. What did you expect from a company like SAS? So I will talk about visualization, and when we started investigating a little bit into the history of visualization, we noticed that in my year of birth, 1972, John Tukey actually was the first one trying to bring into the domain of statistics a program called PRIM9, which worked on a mainframe, in which he said, okay, this is the first dynamic interactive graphics program that he developed, and you could actually turn around data, rotate a little bit. He actually called it PRIM9 allowed for picturing, rotation, isolation, and masking back in 1972. So you have to be conscious that up until that moment, visualization was limited to just plotting out errors and looking at distributions, whether they were normal. For the first time at that moment, data was seen as something you could actually visualize and turn around and gain new insights from. When we try to define visual analytics, so beyond visualization, I think a very important point is that it's not only about preparing, looking at in a visual way, exploring your data up there, but it's also about the left side, about the data itself, preparing the data, making sure it's standardized. So there's a whole lot of work before you can actually visualize that should be emphasized, as you're all very aware from your day-to-day jobs as well. Hand in hand with that goes the models. I think it was mentioned by the previous speakers. It's about gaining insights, but then learning something on how to actually analyze the data. But it also works the other way around. If you look at an analysis and you look at the outcome of the analysis, you might want, in a visual way, learn something about the analysis path that was followed. A statistician might have done a certain technique, data mining, regression, and you want to learn in a visual way. You want to represent it and communicate that information. So visualization is about data management. It's about data mining. It's about statistics. So that's really why, from our point of view, visual analytics and clinical data goes really hand in hand. So what is the difference between gaining rapid insight? And we would like to move or raise the bar a little bit and say, okay, with data visualization, you can gain new insights, but with analytical visualization, that's actually about discovery. If you just let the data speak to yourself, it might be very difficult to see the patterns by itself. It might be, you need to have it prepared in a certain statistical, responsible way. And that's actually what I will be showing you today when we look at some of the clinical data as well. If we look at the data out there that is available, it's actually quite amazing if you look at it. What can we visualize? I will visualize some clinical data later on, but any solution, any visualization, any visual analytics approach should be ready to analyze different types of data from a patient, whether it's structured data at the left side or unstructured data. There's a whole bunch of information out there. There's a world of information about patients, real-world data, clinical trial data, text data from physicians describing comments about their patients, for example, radiologists adding information that could be used at some point to put it in a visual way and to use it as such. And so we are looking and we're definitely dealing with a lot of these type of projects where you have to integrate the data, and there's a lot of challenges behind there, because how do you combine data from a clinical trial data set with data from a health register or from patient outcomes, for example? That's a really big challenge. So if I look at the analytics landscape, although I will be focusing mainly on the right-hand side here on information dissemination, I just want you to remember that a lot of preparation work needs to go in before you actually do the visualization and look at it. It's about having a capability to store the data. It's about the capability to analyze it, whether it's a lot of data, big volume of data, whether it's diverse data, whether it's text data. It needs to be prepared in a very structured way. If you look at clinical trial data, you're looking at endpoints, at clinical endpoints, for example, and you follow a statistical analysis plan. So you need to standardize that data. You might need to convert it into CDISC data, as you're doing, before you actually are able to visualize it in a very standard way. So what data sets will I be using? Well, just one slide explanation before I actually dive into the data set itself. This is for patients that have a bleeding in their brain called scientifically subarachnoid hemorrhage. The subarachnoid hemorrhage is when a blood vessel in the feeding the brain with oxygen and nutrients bursts, for example, because of an aneurysm. What happens is then the brain gets deprived of oxygen, and so you have a hemorrhage and a bleeding. Now, that's by itself a very serious condition from which you can die, but there is actually a very important secondary complication that neurologists want to avoid when they have patients like that. And one of them is that because of the bleeding in the brain, the vessels, the neighboring vessels that surround that burst vessel are actually contracting because of the substances in the blood, so they get irritated and they contract, and that's called vasospasm. And that contraction can then lead to brain ischemia, so the brain is then again deprived from oxygen, and you have a secondary problem in the brain whereby the patient can actually have a die or have a high morbidity and a very worse, very bad outcome from that. So what doctors are doing, they're really trying to avoid that secondary effect. This is a clinical trial that was used to compare a substance called nicardipine. Nicardipine is a calcium channel blocker that is actually going to avoid that vasospasm, so that contraction, that secondary effect of those vessels. And they were compared against a placebo arm whereby nicardipine was not treated, but these other patients did get treatment to avoid blood pressure rising and to have problems with high blood pressure in the brain. So this is the layout, and before I actually move to the demonstration, I will actually show you a visualization, so I require that everything I say you will firmly believe what I show. So what I'm moving forward with is, when I actually share my screen here, is SAS Visual Analytics, which is our solution to visualize data. Again, I haven't forgotten the fact that the data needs to be prepared, and that's actually what we did. The clinical trial data was converted into a standard format, was prepared, was cleaned, and the quality was high, and that's the data set I'm looking at. So at the left-hand side, you can actually see the data set here, and I'm going to explore a little bit the data set at first to look at whether the patients didn't have any toxic effect from the drugs. So I'm going to check out some liver toxicity parameters in the data set. So in order to do that, I will look at drug-induced liver disease. So and I will plot a number of these liver enzymes that are typically followed when you're looking at something like Hy's law. Probably most of you are familiar with Hy's law, that allows you to look at the raised liver enzymes, and that gives actually an indication of the fact whether your drug in effect is toxic for the patients. In a clinical trial, because of the small number of patients, you have to be really careful in picking up those signals and making sure that you pick out those patients that could have issues. So let's look at the level of bilirubin and alanine aminotransferase. Those are actually the two most important liver enzymes to look at whether the drug is toxic. And what I will do is I will just drag and drop the variables in my data sets which are ready and move them onto a visualization panel. Immediately, the best visualization will be chosen. In this case, it's a scatter plot. So let's clean it a little bit for better viewing, and also choose the scatter plot here and perhaps group it by a variable such as a flag, which is in the data set, which indicates whether clinicians actually flagged these patients as having Hy's law. I will add some data tips here, so when I hover over the data points that I actually get some meaningful information from it. And I will also add some cutoff lines, because with Hy's law, what happens is that these subjects that need to be studied further need to have an ALT level higher than 3 times upper limit of normality, and they need to have bilirubin levels 2 times higher than upper level of normality in here. So the cutoff in logarithmic scale, because these are actually logarithmic variables, I will add here a line that indicates that. And I will make a second line available as a cutoff, in this time on the x-axis, with a cutoff here. I should have chosen a new one. So you get to see those cases, and you can hover over those particular subjects and study what actually their liver enzymes were in that respect. So whether also the other liver enzymes were increased. So I'm actually exploring. I have a data set in here. I didn't have any preconceived ideas about how to look at this data set, and I have all flexibility to draw in variables and to look at that. What I will do now is add in the other liver enzyme variables and add that information. What will happen now, I will have a multicellular scatter plot, and if I go over the different points, they're actually interactively linked in between. So I can look at this data in a highly correlated way now. I can look at, for this particular patient, with the bivariate scatter plots to see what the effect is for these subjects. So this is enormously helpful to dive in and to look at the details of the data. If I actually double-click on one of the particular subject points, I get a drill down with a particular scatter plot again, going back to the one that I created initially. So not only that, but I can also create a new visualization. And typically what you do is you want tables. You want to see listings in clinical data. That's what you're used to. And you want that information. And you might want to drill down according to a specific number of dimensions. So what I will do is I will create in my exploration a new hierarchy. For example, I will create a hierarchy here that starts with the highest law case. I will then add the fact whether these subjects were treated, so the description of the planned arm, and I will then count the number of subjects that are in that particular case. I will create a cross tab, and I will search now for the hierarchy that I just created, put it on here, and I can now pick up again my liver enzymes or any variable that is present in here and add it to the table. So in a very rapid way, I now got a way to look into those cases that were Hy's law, that were treated or not treated with nicardipine, for example. And I get a list of the different subject IDs and each of the values that are in my data set. So very simple, very rapid way to drill down in the data. So this is just exploration. Obviously, you want to make that available maybe across different clinical trials, or you want to study, as a clinician, the clinical endpoints in there and see what is now really the effect of that substance on my patients in this case. So what I did is I created a report from that with a little bit more information in it, and I recreated the initial scatter plot that I created together with you here. So having the ability to look at the different subjects and look at whether they're Highest law cases, I recreated the scatter plot so you can make this available for people that don't want to go into an exploration mode but already have the glasses on of the person exploring the data from them. So I can look at the different data points in here. And I have now added an additional visualization, which is the temporal addition. So I can look at some of the information over time. What I did here, I plotted the same liver enzymes, but I added on the axis here, I added the study day coordinates. So now I have the study days, and I can actually animate that and look at what the effect is of these subjects across time. So, as you probably are aware, if you look at the clinical trial, what is really important is that some of these subjects already had liver disease, some of them didn't. But what you really want to know in this clinical trial is find those patients that had elevated levels of bilirubin, of alanine aminotransferase across time during the study, maybe because of treatment with the actual compounds that you're researching. Clearly, there were 2 points here marked outside, so I will highlight one. Let's go back in time and run that once again. Okay, this was the one. Let's do that again. Now the other ones get faded away, and you can actually follow the path of that subject a little bit more clearly and study it in detail. Again, you can create different reports to link them to each other, but it's kind of a good way to study the data closely over different aspects. You can go in and use the other variables in the data set that you have. For example, you can look at the treatment and the placebo arms and correlate that geographically. This was a US-based study. So I can look at the different states if the randomization was intact, for example. As I click on the different states, you see that the numbers are changing in the table above there. So they represent the subjects that were in that particular state. What is interesting is in here I added a little bit of information on a specific treatment. So a Swan-Ganz catheter, which is a catheter that measures pressure in the heart, and that's actually a very difficult procedure with a high degree of complications for subjects and patients. And you might want to know if, with treating your patients with nicardipine, if you could reduce that treatment, because it can save you a lot of money. So even though the treatment effect might be not what you expected according to the statistical analysis plan, there might be an effect in there in the clinical trial data set that are of interest. And that's exactly what came out of this clinical trial. So we could see that although the outcomes were not significantly in a statistical way influenced by the treatment, it did have effect on the quality of life of the patient and the interventions that needed to be done and the whole cost trajectory of that patient in the hospital. As a final visualization and as something that was interesting, I'm looking here at the number of adverse events and a classical tree plot. Again, the different ones are linked, the body system class on top there and the dictionary-derived term below there. And you can click on the different body classes and it will list up on the bottom there the different dictionary-derived terms. What you want to know in the case of these patients if their number of nervous system disorder adverse events went down with your treatment. And so if we click here on nervous system disorders and we look at the nicardipine treated and the placebo treated, that's actually what they saw. They saw that the number of people that were not treated with nicardipine had a higher level of neurological problems. And that's because they had a higher level of, a higher degree of effects in there that were problematic, so a number of complications. I can actually drill down in the nervous system disorders in here and see again what is the effect of the different adverse events, what was the distribution across my placebo and my nicardipine treated subjects. Is it different? So you can look at the effect, the number of adverse events and compare them in a visual way. So these are just a number of visualizations to look into the clinical trial data. And I think a very important point in the previous presentation or a question that came up was, yes, but we are programmers. We need to validate what we've done. We need to show it to authorities. That's what you can do. In this technology, we made available something called ProcImStat, which is in memory statistics. And it's the programming, the SAS programming language way of producing the exact same visualizations as you saw previously. So there's a link between that interactive visualization track and the clinical study submission reports, where you can not only statistically prepare your data, statistically analyze it, but at the same time produce the plots and confirm them and put them in the reports together with your other SAS programs. So what the clinician sees can be handed over to the statistical program and the statistician as such, and identify those relevant endpoints. And I think that's really visualization combined with analytics, visual analytics. 4 key points just to finish off. If you look at clinical endpoint determination, what do we need? Well, it requires a flexible visualization. Clearly, you need a visual tool, and we've seen there are many out there. You need advanced analytics to be able to look at, to do regressions, to do clustering, to do data mining. You also need knowledge management, and with knowledge management, I mean the ability, for example, to look at text data, and to apply semantics, to apply things like ontologies or control terminologies. And you need that in an integrated technology together. Secondly, it's an iterative process. You can do it during the trial, while the trial is blinded. You can do it after the trial, as I have shown you, with an unblinded trial. Or you can do it when you bring trials together across different trials and so on. I think we're in a moment where there's new technology. The whole day we will see those types of technology, and that opens new ways of looking at your data. Structured, unstructured, without limits to volume, by the way. So you can bring together all that hard-earned CDISC data together. You can pull those SDTM data sets together, and for one particular project or a compound or within neurology, oncology, you can look at it at the same time and see what the effects is. I don't think we could do that 10 years ago. So I think it's a pretty exciting moment to be there. And maybe the most important point is the 4th point. You can have statistical calculation as something that is integral with visualization. And I think before, you had many visualization approaches. On the other hand, you had statisticians, but they were not talking to each other. I think now with these type of technologies, you actually integrate both worlds much better. I'm not saying we're there yet, but the technology allows you to improve these processes and to do that. So what is important in there is that it's not just about clinical endpoints, it's about surrogate endpoints. I think most know that with surrogate endpoints, you can reduce the trial, you can kill trials earlier, but you need to make sure that the surrogate endpoint is reflective of the real clinical endpoint. And so you need to make sure that by a good statistical and visualization approach. Hope to have convinced you a little bit of those elements, and with that I would like to thank you and leave you here.
Questions? Ooh.